So in this unit, we're going to talk about distance and midpoints. So what we're going to start with is finding the distance between 2 points. Then we'll find the midpoint of a segment, and then we'll go into finding a missing endpoint of a segment. So first of all, we have some vocab. We have 4 different formulas, and these are formulas that you absolutely positively have to know. So we've got distance, which is just the length of a segment. So we have 2 ways that we can find distance, either on a number line where you do a minus b and then you take the absolute value, or on the coordinate plane where it's actually graphed. And so we have the square root of x2 minus x1 squared plus y2 minus y1 squared. From there we go into midpoint, and the midpoint is just the point in the middle of a segment, which should make perfect sense because it's midpoint, middle point, right? So on a number line, all we're doing is averaging together our 2 numbers. So you just add and divide by 2. On the coordinate plane, it's exactly the same, except we have to do it for x's and for y's. So we add our x's and divide by 2, and then add our y's and divide by 2. Then we go into and talk about a segment bisector, and so that would be any line, segment, or plane that intersects a segment at its midpoint. And so that would make sense because we know that to bisect something is to cut it in half. Bi meaning to, sect is to cross, so it crosses it in the middle. So let's go ahead and deal with some examples using the distance formula on the number line. So the first one that we have is, what is the length of MP? Well, if we're looking at M to P, remember the formula that we're using, because it's a number line, is A minus B inside the absolute value. So what I'll do then is keep absolute value, replace A with our -4, and then minus B, which is 1. And so that gives us the absolute value of a -5, which is a +5. And so that is how long that segment is, which is really just counting how far to get from one to the other. And then in our second example, what is NQ? Well, same exact thing. So you're starting at -2, working your way all the way up to a +5. So if we take -2 and we subtract 5 from it, we get a absolute value of a -7, and absolute value is always positive. And so it kind of makes sense, because when you think about it, if you're traveling somewhere, you're always talking about distance in positive numbers. You're never going to deal with a negative distance. It just doesn't make any sense for that. So that's how you would deal with that. Okay, so now we're going to do the distance formula, but we're going to use the actual formula, and then I'm going to show you a different way. So you actually have 2 different ways to approach exactly the same problem. So using the distance formula, first of all, we need to write down that whole thing. So it is x2 minus x1 squared plus y2 minus y1 squared. So pretty intense, pretty in-depth. And I'm going to go ahead and label these as x1 comma y1, and then x2 comma y2. So that way we can just go and plug everything into this formula as it is. So d equals, we have our square root, and it goes over this whole thing. So x2 would be a -4 minus 2, and then we square it, plus our y2, which is -1, minus y1, which is 3, and square it. Moving on down to simplifying, we have -6 squared plus -4 squared. So from there we have the square root of 36 plus 16. And so we end up with the square root of 36 plus 16 being 58. And now this is not a perfect square, so I'm just going to leave this as is right here. So this is using the actual formula. Now, as we move on, we can actually use a coordinate plane method, which might make a little bit more sense. So the things that you need to know for this, what you might need to recall, is the whole right triangle Pythagorean theorem. A squared plus b squared equals c squared. Okay, so what do we need to know? Well, plotting the point 2, 3 would go here, and plotting the point -4, -1 would be right here. So distance means how far apart are these 2 points if I were to go straight there, not up and over, right? So here's what you're going to do. You're going to look at this distance on the bottom. How far am I going over to get from -4 up to a +2? So how long is this segment right here? Well, it's going to take us 4, 5, 6 total. So that's going to be our 6 squared. Then we have to look at how high up is this going to go? How much are we going from -1 up until 3? Well, it's going 1 and then 2, 3, 4 total. So 4 squared equals c squared. So then as we go through and simplify this, we get 36 plus 16 is c squared, which gives you 58, which is c squared. But you need to get rid of that square root by taking, or square by taking the square root of both sides to get c equals the square root of 58. And c in this case would still represent the distance. It's just a different letter to represent the distance. So you get exactly the same thing, but you only have to deal with this formula right here, which some people are, more in tune with. It's easier to remember. So either one that works. You can use either one. All right, so now we're going to use midpoint and find the midpoint. So I'm using that same number line from earlier, and if we are just on a number line, to find the middle, all you're doing is taking the average. So the formula was a plus b over 2. So if we're looking at the segment NP, right here, we're looking at the points -2 and 1. So I'm going to put -2 plus 1 divided by 2, which would give us a -1/2, right? So a -1/2 would be about here, which is the midpoint because it is 1 and then a half away from each end. So that would be your midpoint, -1/2. Now we have midpoint but on a coordinate plane, so a little bit different. Only the difference is just that we have to do the same thing we did in the last problem. We just have to do it twice. So what is the average for the x's? And then what is the average? That's not that word at all, sorry. What is the average for your y's? So we're going to take our x values of 2 and -4. So 2 plus -4 divided by 2, which would give us -2 over 2, which is a -1. So our x coordinate is a -1. Now for our y's, and I'm going to change the color on this one, 3 and -1. So we're going to take 3, add to that a -1, divide by 2. So 3 plus a -1 is a +2 divided by 2, which is a +1. So -1, 1 would be your midpoint of this segment if you were to connect them. That's your middle. Okay, and then this is our last example, and this is just looking for a missing endpoint, but I'm going to call this the Apellis method. And the reason I call it that is because you're not actually going to find this in a book. It's something that some students and I had kind of come up with to make it a little bit easier on you. So first what we need to do is deal with getting a diagram. A lot of times a diagram is going to make this so much easier on you. So I'm sorry, not J, we're looking for J. So K is the midpoint of JL. So if we have JL, then K is in the middle. Okay, so that's how we would indicate that's what's happening. All I'm going to do is I'm going to turn this and make it vertical instead. So I'm going to put J here, and then I'm going to put L here, and then I'm going to put K here. So all I did was turn it vertically. Now this is what we don't know. This is what we're looking for, right? So K is the coordinate point -1, 2, and L is the coordinate 3, -5. So what we need to look at is how do you get from 3 to a -1? Well, you would subtract 4. So if you repeat that because it needs to be in the middle, -1 minus 4 is a -5. On the other side, how do you get from -5 to a +2? Well, here you have to add 7. So I'm going to add 7 a second time because we need to keep it equal. 2 plus 7 is 9. So our missing coordinates for J are -5 and 9. And it saves you a whole lot of time, I promise, as opposed to using the actual formula and plugging things in.